Hello everyone, I'm SJBIT, working as Assistant Professor in the Department of PC SJBIT. In this lecture, we'll be discussing about computer organization and architecture.
Okay, so here this is a statement, that is some EQU statement does not denote the instruction that will be executed when the object program is run. So in fact that even appear in the object program. So it is simply inform the assembler the name sum should be replaced with the value 200 whenever the areas whenever it is appears in the program. That is, it is going to treat it as a variable. So such statement, it is called the assembler directives or commands. So to illustrate, this figure shows that in order to run these programs on a computer, it is necessary to write its source code in the required assembly language, specify all the information needed to generate the corresponding object program. Suppose that each instruction and each data item occupies one word of memory. This is over simplification, but it helps to keep the example straightforward, and also assume that the memory is byte addressable and that word length is 32 bits. Suppose all the object program is to be loaded in the main memory. The figure shows the address where the machine instruction, these are the address where the machine instructions and the required data items are to be found. So after the program is loaded for execution, if the assembler is to produce an object program according to this arrangement, so it has to know how to interpret the names and where to place the instruction in the memory, where to place the data operands in the memory. To provide this information, the source programs may be written in the next program, next figure. So this is the figure which is going to show the program begins with the assembler directives. So that is the EQU, which informs the assembler about the value of sum. The second assembler directive is origin. So tells the assembler program where the memory to place the data block that follows. So in that case, the location specified as the address 204. So since the location is to be loaded with the value of 100, data word directive is used to inform the assembler of this requirement. It states that the data value is 100 is to be placed in the memory word, at address of 204. So any statement that results in instruction or data being placed in a memory location may be given a memory address label. So the label is assigned to the value equal to the addresses. So address of that location, because of data word statement is given the label n, and the name n is assigned to the value of 204. So whenever n is encountered in the rest of the programs, it will be replaced with this value. Using n as the label in this manner is equivalent to using the assembler directives. So that EQU informs the assembler that the variable name should be replaced with the value specified. So the sum value should be replaced by the value of 200 whenever it is appears in the program. Origin tells the assembler to program whether in the memory to place the data block that follows. So in this case, the location is specified by the address as 204. So what is data word? So data word is inform the assembler that the data value specified is to be placed in the memory word. So in this case, the data value 100 is to be placed in the memory word at address of 204. So any statement that results in the instructions or the data being placed in a memory location may be given a memory address label. So the label is assigned a value equal to the address of that location. Okay, so here the reserve directories declares that memory of 400 bytes is to be reserved for data. So that the number M1 is to be associated with the address of 208. So that this directive does not cause any data to be loaded in this location. So data may be loaded in the memory using the input procedure. So the second origin directive specifies that instruction of the object are to be loaded in the memory starting at the address of 100. It is followed by the source program instructions written with the appropriate mnemonics and syntax. So the last statement in the source program is the smaller assembly directive end, which tells the assembler that is the end of the source program, and the end of the directives includes the label stack, so which is the address of the location at which the execution of the program is to begin. So most of the assembly language require the statements in the source program to be written in the form of label, operation, operands, and comments. So these four fields are separated by an appropriate delimiter. So typically one or more blank characters, and the label is an optional name associated with the memory address where the machine language instructions produced from the statement will be loaded, and the labels may also be associated with the address of the items. So as shown in the figure earlier, there were 5 labels, that is sum, n, m1, and the start or the low. So the operation fields of opcode, mnemonics of the desired instruction and assembler. So the operand field contains the addressing information for accessing one or more operand depending on the type of instruction. So the command field is ignored by the assembler, so used for the documentation purpose. Okay, so the source program written in an assembly language must be assembled to a machine language object program before it can be executed. This is done by the assembler program. So the assembler replaces all the symbols denoting the operations and addressing modes with the binary codes used in machine instructions, and replaces all the names and the labels and their actual values. So assembly and the execution programs. So here a key part of the assembly process is determining the value that replaces the name and is in some cases. So branch offset, as the assembler scans through the source program, it keeps track of the names and numerical values that corresponds to them as in a symbol table. So when the name appears a second time, it replaces with its value from the table. So assembly, the two pass assembler, during the first pass it creates the complete symbol table. At the end of this pass, all the names will have been assigned to the numerical values. So the assembler then goes through the source program a second time, the substitutes value for all the names from the symbol table. So the assembler stores the object program on a magnetic disk. So object program must be loaded in the memory of the computer before it is executed. So the utility of the program called the loader, and it is used to load the object program into memory. So the assembler can also detect and report the syntax error. So debugger programs helps the user to find other program errors and the system software. So this program enables the user to stop the execution of the program at some points of interest and to examine the contents of the various processor, register, and memory locations. So this is what are the number notations. So number notation, it is often convenient to use the familiar decimal notations. So that is add #93 will give the decimal number that is going to be copied to the R1. So these values are stored in the computer as binary numbers. So in some situation it is more convenient and specify the binary patterns directly. So that is, it is going to take the huge number of bits, so that is hash percentage of 0101101, R1. So the binary numbers can be written more compactly as hexadecimal or hexa numbers. So these numbers can be written as hash of $S as 5D, R1. So this is going to be more convenient instead of specifying the binary patterns. So if you go for hexadecimal number system, it is more convenient to use. So the remaining binary numbers can be written more compactly using the hexadecimal. So in which 4 bits are represented a single hexadigit. So X notation, it is a direct extension of BCD code given in the appendix. So the first 10 patterns 00002 to 111 can be represented, that is 0002, that is 101, which is represent the digit as 0, 1, 9 as in the BCD, and the remaining 6 4-bit patterns, that is 1010 to 111, are represented by the letters A, B, F. So in hexadecimal representation, the decimal value 93 becomes 5D. In assembly language, the hexa representation is often identified the dollar sign prefix. Thus can be written as add dollar hash dollar 5D comma R1. Thank you.